I apologize for that interruption. Let's continue. So I'm factoring out my denominator that I set equal to 0. So then I have x squared. Let me erase that and write it again. So I have x squared minus 4x plus 4 is equal to 0. And then I can get rid of this x by dividing both sides by x, right? So that x just goes away. So this x is gone. So I'm just dealing with this. X squared minus 4x plus 4 is equal to 0, because 0 divided by x is just 0, right? And this, I'm going to factor it out. So I'm thinking of what number can I multiply, or what two numbers I can multiply to get positive 4 and add to get negative 4. So that is just going to be negative 2 for both of them. So I have x minus 2 and x minus 2 is equal to 0. So that means that x minus 2 is equal to 0 and x minus 2 is equal to 0. Because they're the same, I only have to deal with really just the one equation where x is equal to 2. This is going to be my vertical asymptote. Okay, that equation right there, x is equal to 2. Okay, for my horizontal asymptotes, there's 3 different cases. So it depends on what you have. So if your numerator, and you guys can refer to your handout for this, if your numerator is less than your denominator, and we're looking, actually, let me go back and explain this. So if you're looking at the degrees of your numerator and your denominator for this. So if we go back to our equation, what I am looking at is the degrees for my leading term, okay? So in this one, the degrees are the same, right? What I'm going to be looking for each time is looking at the degrees and trying to see if the degrees in the numerator and like what the relationship is between the degrees in the numerator and the degrees in the denominator. So if the degrees in my numerator, make that a little prettier, if the degrees in my numerator are less than the degrees in my denominator, then y is equal to 0 is my horizontal asymptote, okay? So that's situation number 1. If the degrees in my numerator are equal to the degrees in my denominator, okay, then y is going to be equal to the leading coefficient for the numerator, which we'll call a, over b, which is the leading coefficient for the denominator. So basically, if we go back to our example, I am looking at the number of the leading coefficients, that number there. So there's no number there, but the number that we are assuming is there is a 1, right? So for this one, it would be 1 over 1, which is just 1. So that means that the horizontal asymptote for my example is going to be y is equal to 1, okay? And my third possibility is that if n is greater than d, so that means that the power for the numerator is, or the degree of the numerator, sorry, is greater than the degree of the denominator. If this is the case, there's no horizontal asymptotes. Not no asymptotes, just no horizontal asymptotes. There is a special situation where if n is greater than d by 1 degree, you're going to have a slant asymptote, and I will give you guys an example of this after I'm done with our current example. Okay, so for the example that we have, our horizontal asymptote fits in with this situation where the numerator and the denominator have the same degree. So that means that our horizontal asymptote is going to be 1 over 1, because that's what we had. Okay, so for our current example, y is equal to 1 is the horizontal asymptote. Okay. All right. So now that we've done that, the next thing that we want to find is points. Okay. So what I like to do when I am graphing these are the things that I want to look for first. I want to look for the holes, the asymptotes, which include our vertical asymptotes and our horizontal asymptotes. Okay. And then the next thing that I want to do is just start graphing it. Okay. And what I am doing when I graph it is, let me draw my x and y axis. What I'm doing when I'm graphing it, I first, without knowing any points yet, except for maybe the holes, what I want to do is draw in the asymptotes. Okay. So for this one, my vertical asymptote is x is equal to 2. So at x is equal to 2, I know I'm going to have a vertical asymptote. Okay. And then at y is equal to 1, I have my horizontal asymptote. All right, now, there's one thing that happens with the horizontal asymptote that is not true for the vertical. On a horizontal asymptote, you can actually cross it. Like your graph can cross a horizontal asymptote, which kind of doesn't make sense. What happens is that sometimes the asymptote is only for part of the function, not the entire function. So there are parts of the graph that might cross your horizontal asymptote, but it will never cross any vertical asymptotes that you have. Okay, so you should never have any part of your function crossing a vertical asymptote. Okay. All right, so now that I know where my asymptotes are, this is going to help me to see where I can get some values of x so that I can figure out where my points are going to be. Okay. Oh, the other thing that I want to make sure that I plot is if I'm going to have any holes, if I know where the holes already are. So for this one, I already know that I have a hole at 0, 0. I also know that I have a hole on x is equal to 2, but that's where my asymptote is, so there really isn't a hole there. It's just, there's nothing there. But there is definitely a hole at 0, 0, so I am going to just draw that hole. Okay. All right, and then from here, as I said, I'm just picking out values of x. Oops. All right, I'm just picking out values of x that make sense to this graph, and then I'm figuring out what the f of x is. So what makes sense on this graph is to maybe go back to like -4 and go all the way over to maybe like 6, okay? So my values of x are going to determine my values of f of x, right? So I'll go back to -4, -3, -2, -1, oops, 1. I'm going to skip 0 because I already know there's no point there. So I'm just going to go in 1, 2, 3, 4, 5, 6. Okay, and if I feel like I need more numbers, I can add more numbers. Okay, and then from here, I am taking my entire function, which was, if we remember, x cubed plus x squared over x cubed minus 4x squared plus 4x. And all I'm doing is plugging in the x values into the function to figure out what my y values are going to be. Okay, and then you're just plotting the points. If you don't see what the shape is, then you can go back on your x values, or you can add more positive x values. If you need to add fractions to it because you think maybe something interesting is happening at like a half, because of the numbers that you see, then you can go ahead and do that. So all you're doing is just picking out as many points as you can so that you can figure out what the shape of this is. And then you just plot your points just like we did yesterday with the inverse functions. Okay, and that's about it for that. I do want to explain for the slant asymptotes. So with slant asymptotes, you are only going to have slant asymptotes if you have a situation where your numerator is 1 degree up from your your numerator is 1 degree up from your denominator. So for example, and so this is an example. So if we have, oops, that's the wrong number. If we have x cubed minus x and 3x squared minus 6x minus 9, if I look at the degrees for my leading terms, I can see that my denominator is 1 less than my numerator. So what I do in this situation is first, forgot to switch back. First, I'm going to take my function and I'm going to factor out anything that I can factor out. So, because first I need to look for holes. So I'm going to factor out an x from the top. And I have x squared minus 9, which that's the difference of squares. I can actually factor that out even more, so I'm going to do that in a minute. And then here I can see that I can factor out a 3. And then I have x minus 2x minus 3. Okay. So I can factor that out even more. So then I would have x times x minus 3 times x plus 3, because that's what I get when I have the difference of squares. And then on the bottom, I have 3 times, and that factored out is going to be x minus 3 and x plus 1. Okay. So looking at this function, I can already see that I have a hole, okay? So then I've identified a hole. Oops. I have a hole at x is equal to 3, okay? So that means that at x is equal to 3, any point that exists on x is equal to 3 is going to be a hole in my function. It does not exist, okay? That's the first thing that I do. The second thing that I do is to figure out what my slant asymptote is, I actually have to take this function and I have to divide it. So I am doing the division that is shown here. So my division is, you're just going to use long division. I have 3x squared minus 6x minus 9. I'm dividing that into x cubed minus 9x. So I'm going to put in the things that are missing so that I can divide this properly. Okay, so I'm putting in my zeros for the things that are missing. It doesn't matter if I have a remainder here. Whatever equation I get here without the remainder, so whatever answer I get here, that line, because it is going to be a line, because when I divide 3x squared into this equation, I am going to get a linear equation out of this. That linear equation that I get is going to be my slant asymptote. And when I have a slant asymptote, what that means is when I graph my function, I'm going to end up with an asymptote that is a linear equation. So I'm not going to finish this one, but this is a separate example. If I had ended up with like x minus 2, that means that I have negative 2 as my asymptote and my slope is 1. So that means that this line right here, which I'm not drawing very straight, but this line right here would be my slant asymptote. So my function doesn't cross that line at all. Okay. All right. So that's it from what I'm explaining for you today. I know it's a lot. Try to do as much as you can. I am also going to be posting a video from Khan Academy. So if you're still confused and you want to see some more examples, I will be posting that so you can see those examples. And anything that you guys can't figure out together, skip it and we'll go over it together on Friday. Okay? All right, have a great day and I will see you, I hope, tomorrow. Okay, bye.